A very good morning to everybody here. Um, uh, a hearty welcome to IACEST 2023. I would like to extend a very warm welcome to Ms. Minimol Korulla for presenting her keynote titled Sustainable Slope Stability Solutions Using Flexible Technologies. Thank you, ma'am. Thank you for accepting our invitation and making time. Before we begin, I would like to introduce you to the audience. Ms. Minimol Korulla has completed her BTech in Civil Engineering from MACE Kottamangalam, Kerala, and MTech in Geotechnical Engineering from CET Trivandrum, Kerala. She is having more than 25 years of experience, industry experience in landslide mitigation, ground improvement, and flood control. She is a part of code formulation committees of national and international forums like ISO, IS, and IRC, and is committed to bringing sustainable and innovative technologies to practice. Presently, Ms. Minimol Korulla is working in McAfee as VP and Head, Strategic Projects and Initiatives for India and Southeast Asian countries. Welcome to IACEST, ma'am. I request you to start presenting your keynote. Thank you.
So, flexible technology, I was talking about the left-hand side photograph where the pointer is buried. There we have seen the barriers, two barriers, which are installed there as a part of the landslides. And these barriers are meant for holding the rocks without falling to the road just below it and causing the accidents. In the right side, this is in fact a project which is installed in Bangalore only. It is done for Tata projects, and they were developing a vast real estate development area, and there a 15-meter retaining wall they constructed as a reinforced soil system with the geogrids in one part with a flexible fascia. The fascia is made of, again, a flexible system. In some other part, they did a combination of the soil nailing with a flexible fascia. Okay, so 15-meter to 20-meter high retaining walls are being constructed with the geogrids, which are flexible materials, and a flexible fascia, which is being made with the steel wire mesh gabions filled with the stones. So no concrete, no mortar, or any rigid materials are being used in this project. It is completely made with the flexible materials. So there are a number of systems are there in the present world, because the present world we can see the age-old concept of the concrete structures or steel structures. That's what everyone was using in the majority of the structures. From there, the change has come. The world is now aware that, especially the construction world is aware that we may have to look for alternate technologies and more resilient type of systems. Okay, and several families of materials are getting evolved, and so many researches are going on. And I want to introduce few flexible systems. And the concept everywhere is the systems which can accommodate more movement or more the strain it can take, more deformations it can take. That doesn't mean that there is no limit for that. Of course, there are limits we have to apply. We have to apply the serviceability criteria, but it is much more accommodating the movement compared to rigid systems, and this will help the resilience concept. So that by just saying few families of those type of materials, we can try to define that how these type of materials, with its flexibility, it will be contributing for more resilient structures. So the first one is the simplest, mechanically woven steel wire mesh materials. In that, there are a number of type of products are there, but the base material is a mechanically woven steel wire mesh, which can be formed into different types of shapes like boxes, rectangular boxes, or cylindrical boxes, and those can be filled with the stones or equivalent type of materials, and that can be used as building material or building blocks. Okay. So there is a Indian code IS 16014, which was first published in 2010, and it got modified and republished in 2018, which is talking about the specification of this type of materials, this steel wire mesh box filled with the stones. Indian Road Congress for highways, they also published a guideline which is more talking about the design and construction steps. So IS 16014 can be referred for the material specifications, and for the design aspects we can go to the Indian Road Congress publication 116, and the same is again quoted in the MORTH handbook, which the highway engineers are considering as the Bible. So which are the major products which I want to introduce here? The first is Gabion, which is very popular. People knows about its plus and minus, but when it is coming to the flexibility, this is one of the most flexible product which is available for infrastructure protection. It is the box which is made with a mechanically woven steel wire mesh, and its sizes usually will be 1.5 meter length, 1 meter width, and 1 meter height, or it can be, the length can be 2 meter or 3 meter or 4 meter. So this is as per the different codes which I already mentioned. If you don't want that much height, we can go for 0.5 meter box also. So in this visual, you can see the given boxes which are filled with stones, which is acting as a toe wall for a slope, and this particular structure that is constructed in a riverbank slope protection in Bihar. What you are seeing, the visual where my highlighter is moving now, this is in fact a very tall slope stabilization which is currently getting installed in Jammu, and this structure, this is not a structure like this where simply a gabion or a box with a steel wire mesh is filled with stones and it is used as a building block. The Jammu structure which I mentioned here, the box is being used only as a fascia, whereas the geogrids, polymeric material, is acting as a reinforcement which is going inside the soil, and that is acting as a reinforcement. So both the geogrid, which is acting as the reinforcement, and the fascia, which is a gabion filled with the stones, or in the upper part of the structure. The gabion part you cannot see clearly in this photograph. It looks the same as this Bihar structure, but the upper part where you are seeing greenery, there gabion and stones are not there. The fascia is just the woven steel wire mesh elements which is vegetated. So the geogrids are going inside the soil, and there is a fascia which is a woven wire mesh elements which is in a C-shaped way, and their vegetated soil is filled and it is enhancing the vegetation. So the structure which this Jammu in the Jammu where it is getting installed, there are two types of flexible systems are being used. One is the polymeric material which is going as the soil reinforcement, and then the fascia where the bottom blocks are the gabion and the upper portion is just the vegetated woven steel wire mesh. Then there are sag gabions. What is sag gabions? So I'm talking from Kerala, and here a lot of flood-induced slope instabilities are happening currently. Every day in the paper, the last 4 or 5 days, I was seeing a lot of flood-affected slope instability problems. So if we have to repair it as an emergency project, the sag gabions may be the right solution, because even in an inaccessible place, a cylindrical shaped wire mesh cage we can fill before, or we will call it as a pre-filled gabion, pre-filled cylindrical gabion, and that can be dropped from the bank by mechanical means or manual means. Most of the time people use cranes and some divers to place this type of sag gabions in a flood affected riverbank slope. Now the second set of family, what I want to introduce here, those are polymeric materials or geosynthetic materials. The different types of the geosynthetic materials are geotextile, geogrid. I already talked about the GEMO structure, where reinforced soil slope, where the geogrids are used as the reinforcement. So the geogrid is a very popular product nowadays. We can be proud, because in the whole world, in the global scene, India constructing maximum reinforced soil structure with the geogrid. If in other countries, developed countries as well as undeveloped countries, if the construction is going in thousands of square meter, in India it's going in lakhs and lakhs of square meter, especially in national highway, as well as different zonal railways, and even for the construction of different airport slopes. So the geogrid is mainly acting as the soil reinforcement system, and it's really proven as a very effective way of giving the flexible, long-standing composite systems which can stabilize and protect our steep slopes. Now, there is a third product which is called a geocomposite. So all these are generic names which is mentioned in different codes and guidelines. But when that is getting produced by different manufacturers, they will use their the brand names. But if you can type in Google of the geotextile or geogrid or geocomposite, you can get the properties as well as the specifications and a number of case studies. And in that, geocomposite is somewhere a lot of case studies are getting installed at present in India. What is a geocomposite? Any two geosynthetic materials, when they are getting combined, we can call it as a geocomposite. But the most popular material at present in India, especially for slope stabilization, it is a drainage geocomposite. Okay. So the drainage geocomposite is a drainage net sandwiched between two geotextiles. That is the most popular product. There are a variety of other type of drainage composites are there, but I am concentrating only on this. The drainage net sandwiched between two geotextiles. And this is magically replacing the normal gravel drains because of mainly two reasons. One, it is imparting a lot of cost effectiveness. The gravel drains 600 mm or 300 mm to 600 gravel drains is really become a very expensive solution nowadays, because the stones and aggregates are becoming more and more scarce. The use of these natural materials, we don't know how much we can continue. By 2030, it's heard that there won't be this type of material at all. So the geocomposite is a very good replacement. Second, it is quite cost effective. The compared to a gravel train, the geocomposite will be having only 1/3 of the cost, and the productivity at the site is again commendable compared to a gravel train. And the fourth member of the family, geomat. The geomat is something which is a erosion control mat. We know that there are bioengineering materials like jute as well as square, which are also flexible, which are also quite effective as economical solutions, as well as quite cost effective. But the geosynthetic mat, in certain situations, that may be better than the bioengineering material, and it can work with the bioengineering material also. So the image what you are seeing, this is a 3D geomat which can be used for using as the fascia of steep slopes. Suppose we are going for a soil nailing or anchoring. If you don't want to go for a rigid fascia like short crane, we can go for a 3D mat. And this 3D mat will facilitate the vegetation growth, and it can act like a small check dams. Whatever the rainwater or the surface water or even subsurface water, if it is flowing through it, the energy will get dissipated. Now I want to talk about the special set of materials which are being used more in landslide prone areas. I heard Professor Nilima was talking about the Uttarakhand, the slope instabilities and the type of the studies which have to be conducted as well as the monitoring. So I'm talking about the various structures which are being constructed after the 2013 landslides in Uttarakhand, as well as the tragedy which has happened in the Maharashtra Mumbai-Pune Expressway in 2015. 4 or 5 people died because of rockfall. So now the disasters are in control in many stretches of Uttarakhand, as well as in Mumbai-Pune Expressway. So the first, I already talked about the steel barriers. These are steel barriers. The steel barriers are one type of flexible systems which can be used for landslide and rockfall control. Another type of flexible systems which are being used, those are drapery systems. So it's draped along the rock surface and the rocks will be folded up to some 60 centimeter blocks. If rock blocks are or rock boulders are falling, we can go with the normal double-twisted mesh which are being used for the making of gabions and mattresses. But for higher, suppose in 3 meter by 3 meter, that above the rock is full, then you cannot go with a simple double-twisted mesh. We may have to go for the high energy absorption cable net. Okay, so I'm just telling this to indicate that there are different types of drapery meshes are popular, and those are being clearly specified in different guidelines. There are 3 guidelines I will recommend if you are interested to see what are the different drapery systems as well as the barrier materials. Okay, IRC HRB 23, that is Indian Road Congress Highway Research Board, which is published almost 6 to 7 years before. Then 2 ISO specification, ISO IS 17745 and 46. Those both the ISO are already adopted in BIS, and these are giving the specification as well as the testing standards of different materials which can be used as the drapery mesh as well as the barriers. And these barriers will be having different certification systems which will tell them what type of energy it can absorb and how much it can be really subjected to the deformations and other type of movements. Then there are umbrella systems. So this is a new development which can be used in disaster affected areas for especially for if a emergency protection we have to establish. So umbrella system means it's a combination of this type of a drapery mesh and the nails. Usually, if we have to do a slope repair, we may have to go and do the nailing first and then a fascia. Whereas an umbrella system, like an umbrella, it is having a central nail and then it will be having a fascia system together. So a 2 to 3 meter slope protection systems has to be established quickly. We can go for it. Like simple cut slope stabilization. What you're seeing the two visuals, the upper one is Mumbai-Pune Expressway. I mentioned that in 2015, the July or August. So 4 or 5 people died due to the rockfall. After that, the authorities has established a quick tender, and this portion where you can see there are some barriers which are established there and drapery systems are there. But in fact, the drapery systems here, those are acting as fascia because the main heroes are the reinforcement, the nails which are going inside the rock and stabilizing the unstable rock depth. And when I'm telling the reinforcements are the main hero, I mean forgetting the main supporting actors. They are the drainage holes which are provided and the drainage pipes, without which definitely this problem would not have control. So deep drainage mechanisms are introduced there. So the combination of the drainage provisions, the nails, and these fascia systems and barriers, or we can tell as the flexible systems, those are protecting the rock slopes of Mumbai-Pune Expressway. And what you are seeing down, that is a structure which is being installed in 2016 to 2018 in Tamil Nadu Kerala border, and it seems that it is a very small slope. When we are looking this photo, it's only means let's say maybe 2 to 3 meter, but it's not like it is almost 13-meter high slopes where the bottom portion of this slope is nailed with the soil nails, and the fascia is made with the three-dimensional mat, which I explained in as geomat, and hydro seeding is done for bringing the vegetation. So I introduced different type of systems, and the common merits which are contributing for these systems are reduction of materials and waste material. So most of the time, for example, if a riverbank slope which is subjected to floods, that is getting controlled by different types of retaining walls or maybe lining materials, or sometimes the WRD, the water source department, they used to dump a lot of stones. Or if it is a coastal slope, one may go for tetrapods. Okay. Many of my friends in WRD, they used to tell that they used to ask the contractor to double material because the material will get washed in. So it is a flexible system. When we are putting riprap or tetrapod and all, those are flexible. Even if the concrete tetrapod, we can tell that each individual tetrapod is a rigid material, but altogether it's a flexible system. But by using gabions or cylindrical gabions or mattresses, we don't have to go for double because those are very tangible. It can be numbered, and we have to use only the right one. The second is the wastage will be minimized. Then the third merit is these materials or the systems can be reused. So we have seen in Mumbai-Pune Expressway or in Uttarakhand slopes, a number of barriers are being used. But After the rock impact, a rigid structure may be getting completely destructed. But these type of barriers, the steel barriers, they are certified for n number of repetitions. Then life cycle impact. Most of these type of materials are, if they have to be used, they have to be certified. And the life cycle performance analysis is a part of it for the certification. And it is more predictable. And mostly these certifications necessitates 120 years of durability. So we cannot think, say, I'm given only a 30-minute session now. We won't be able to go deeply into that. But whatever the systems which I have introduced here and which is already in international as well as Indian standards, our Bureau of Indian Standard as well as the IRC. So all these are with the durability minimum 120 years. Then vegetation regrowth. Almost all these systems which can accommodate the vegetation and it will not prevent or block the growth of the greeneries, and there is no requirement of the tree cutting. Recently, I was so happy that one of the clients has informed that by usage of this type of systems in a riverbank protection area, they have saved 893 precious trees. So that was only possible by the usage of this flexible systems. If we were adopting a retaining wall with concrete or masonry, they would have cut almost all these trees which I mentioned. So, Professor Bhargavi, can I take a few more minutes? Because in fact, my time, which was given earlier, it is over, but I want to show some case studies.
Yes, ma'am. Yes,
is it possible?
Please go ahead, ma'am. Please go ahead, ma'am. No problem.
Okay, I shall go fast.
Yes.
Okay. So I was talking about the riprap and all can be replaced by this type of material, and it will reduce the cost as well as the durability will be increased and the waste will be reduced. So to demonstrate that, I am showing this is in fact from a case study where initially riprap was being used and the thickness was almost 2 meters. Okay, the thickness which was being designed by the CWPRS, the lining is a reference law. But then by discussion, the consultant of this project, they have told that we can go for matrices which are interconnected, which will be monolithic, and we can reduce from 2 meter, that can be reduced to 0.5 meter. Okay, when a thickness of 2 meter is getting reduced to 0.5 meter, and that is for kilometers of riverbank protection, the project has reduced its cost almost 1/3. So the initial 28 crore has reduced to 21 crore. But there it didn't stop. It again got optimized, and the final structure that has become half of the initial one. Instead of 28 crore, it has got reduced to 13 crore because the further optimization has led to the thickness adopted as instead of 0.5, it has got reduced to 0.23 meter. Okay, so this is the type of the saving of the cost as well as big jump to the sustainability. When we are reducing the use of natural material, you all know that we are doing more green. There is a carbon footprint reduction and big contribution to sustainability. Okay. So then I was talking about we can for inaccessible places and all, when we have to do the construction immediately after a flood, we may have to go for dewatering, we may have to go for the very complicated type of installation procedures and all. But these type of simple flexible materials with a few simple machines, those can be placed very effectively. And for flood control and it can be placed repeatedly in a number of places using the same type of systems. And I talked about rainforest soil system, which is going with the geogrids with the different types of fascias. So this is again, we can go with the whatever the material which is available locally. Nowadays in India, the very tall structures are getting constructed, like 40-meter, 60-meter high rainforest soil systems are getting constructed, especially in the airports and railways. So these are the images from live case studies. And as I mentioned that, there are a number of certification systems are there. So if we have to use in public sector projects, we have to produce these certifications. And these certifications are very strict, after very strict evaluation of how much durability one can expect from the use of these materials. And flexible systems, it's one of the big merit is it can accommodate a lot of greenery. So aesthetically, it will be pleasing, as well as the ecosystem will become a part of the system. And while in a concrete structure, the trees, if it is the roots are going through it, it can degrade the structure. It can create cracks. Whereas in this case, the structure will become more stabilized and strengthened. We talked about the drapery system. This is the drapery system which is placed in a case study, which is from Nasik. There is a Saptashringi temple, and there the temple was getting damaged by the rockfall from a hillock, which is almost 200 meters and standing vertical just behind the temple. So we can see the drapery system, the steel meshes which are being placed. Here, this is being placed using the helicopter because there was no accessibility. So that is again one of the advantage. Wherever accessibility is not there, also it's possible to place. Maybe you may have to use the climbers or the helicopter, but it is possible. So we can protect our hill slopes as well as our precious temples which are placed in such type of inaccessible places. This can be used. But at the same time, so definitely testing of these materials are a must. We cannot use by just like magic. There are different ways of testing of the materials are there. One of the major tests for this type of drapery systems as well as the barriers are punch shear test. Okay, because when the rocks are hitted, these meshes are getting hit by the rocks, we have to see that it is not getting damaged. When it is coming to the barriers will be holding the rocks which are coming through a projectile motion. So the energy absorption capacity should be there with the barriers. And this also can be tested by different methods. And one of the most common test which is being used is a crash test. Crash test is test barriers will be placed at the foot of a hillock, which is a natural hillock, or artificially we can create it. And then from the top of the hill, heavy concrete blocks, which are representing the rocks, will be made the projectile motion. And once that is getting hit, we will be seeing that how much deformation the barriers will be subjected to and how much the capacity the barrier can withstand. So now we are seeing a case study which is being done in Uttarakhand. So this is a case study which is very near to the Badrinath. It's a place called Lambagar, and we can see a rainforest soil system which is almost 40-meter high. In fact, it is one of the tallest rainforest soil structure in Uttarakhand. And here, the materials which are being used are the same which I introduced earlier. A bonded geogrid which is going as the reinforcement, and the fascia is our variance with the matrices. Okay. And this structure, the case study, I have shown in the first slide itself. And this is in the Jammu, a rainforest soil structure, which is the fascia systems are completely vegetated with the greenery, you can see that this is again a structure which is very tall. It is almost 60-meter high. So the function of the flexible systems which are being used, it made possible this type of a retaining system. If it was RCC or masonry, this much height could not have gone in such a steep way. Then we may have not very eco-friendly approach by acquiring a lot of land and constructing heavy concrete structures. So definitely this type of a reinforced soil structure with a flexible fascia made it possible for such a big height, and it is completely covered with vegetation now. Okay, you can see the close-up. So this is the again a slide which has happened in Uttarakhand. You can see how the entire behavior of the slope during the time of the slide, and the happy news is that it got completely stabilized by this time, and you can see the composite structure which is being constructed there. So this is a place called Birahi, and here a 25-meter high reinforced soil structure is being constructed in the valley side of this road, and the hillside a number of rockfall protection, drapery systems and barriers are being placed. So this is a structure which is being instrumented. The piezometers, the strain gauges, pressure cells, as well as deflectometers are placed here. The last 4 years, this structure is being monitored, and maybe by end of this year, the complete monitoring will be reviewed. And so far, my information is that the deformations are very much within limits, and the structure is performing in a perfect way. Okay. This is a structure which is an emergency structure which is in Kerala, NH47. A sudden slide has happened, and it was rebuilt using the simple gabions as a gravity structure. But it is a toe wall. A big slope is there. And recently, we have asked one of our engineer, Rohit, to go there and take the photograph of this structure. Okay. Rohit has taken the photograph and he has shared with us, and we won't be seeing any gabions. Okay. But gabions are there, but we are not able to see it because the trees and bushes and the herbs, shrubs, everything, and creepers that has completely covered the structure, and the slope is totally stabilized. And this is another structure again in Uttarakhand. It is a place called Nandapraya. And more than the given structure, I want to talk about the cascade drains which are being placed here. So these cascade drains are acting as very good drainage system as well as energy dissipators. And again, for the landslide mitigation in Kerala, in Uttarakhand, this is a drapery system what I was talking about. You can see that the drapery system is covering, and it is protecting the road below by preventing the rocks to fall on the men and the infrastructure. And it's not only in highways, in railways also it is effective. One of the most prominent case study for the rockfall prevention, that is in Konkan Railway. This is another, whatever the photograph you are seeing, this is in Assam for North Front Railway. Again, Mumbai-Pune Expressway, I am skipping it because you have seen this. This is for the BRO Vartak, Arunachal Pradesh. This is our umbrella system. You may be remembering I talked about the combined system where there is a nail, a central nail, and a umbrella type fascia. This can be constructed within few days, where this type of a protection system, sometimes it will take months and months, but in Arunachal and all, the work window is very less, and the BRO wanted to do it very fast. So that's why this type of a umbrella system is adopted. And the specification and the testing criteria and all, IRC is now coming out with a guideline. It's already, the process has completed. It's only the printing is awaited. And maybe by October, November, it will come out. The umbrella system, the testing criteria, the specification, everything is completely covered. So this is again our the data structure in Bangalore. as I mentioned that here two types of flexible systems are used. One is the soil nailing, the other is the geogrid reinforcement. But the fascia is again flexible. It is the gabions with the stones. And in this case, some type of movements were observed, which we were really we became very careful, and the complete monitoring has happened, and it has seen that information or the movements which was happening was something between 200 and 250 mm. But for a flexible system, it is permitted to go up to 500 mm. So this 200 mm was quite within the permissible limits. A rigid system, we may have to limit it with the 25 mm to 40 mm. So that is the big difference or the big merit we are getting with the flexible systems. So we have seen this case study, so I'm skipping it. And as a last case study, I want to say that when we are going with the systems in places like Himalayan slopes, it will be a series of systems. Okay, so this is one a solution system which is being used in a place called Govind Ghat. So this is the initial site condition. The road was completely damaged by rockfall and slides, and a continuity of the road had to be established for the Chardham Yatra, which is a spiritual pilgrim. Every year, pilgrims used to do this Uttarakhand visit, and this stretch was quite important. And we can see that a number of systems are being done together. Okay, so we can see the nailing, then reinforced geomat, hydro seeding, then reinforced soil system with the geogrids. Then there is at the top, I don't know whether it is visible to you, the top gabion walls, and a river is going here, Mandakini, which is a tributary to Ganga. So for the Mandakini river, it is damaging the river bank. So that slope is protected with the gabion wall and mattresses. So when we are doing this type of a system, we have to start from the first principle, and from the catchment area mapping onwards, the hydrological, the geological and geomorphologic studies are to be done first of all, and the global analysis need to be done. And for the flexible systems, most of the time, its main advantage is that we don't have to go for so many construction joints or expansion joints, and it is repairable also. While we are doing the systems in this type of risky areas, a number of times during the construction itself, the slides and rock falls can happen. And these structures, while we are doing, we can repair very easily. So some more photographs of the Govind Ghat. You can see again the destabilized the stretch before the rockfall protection systems are installed, and this is not after. In fact, during the construction, during the installation of the different types of drapery systems and toe gabions, and this is the complete. Once the installation is completed, the road became open for traffic, and the slopes are now more safe and stabilized. You can see that the different photographs now, the horrifying, risky situation has completely got controlled. Okay. So this is another stretch in continuity to that, Gulab Koti, where the rock outcrop was there, which had to be cut and then stabilized. So the systems which are being used, again, complete flexible systems were being used. So rock anchors and the fascia with the drapery system, and the drapery system fascia which is being used is a cable system which is called a high energy absorption panels. So which can take the rocks of size of 3 meter by 3 meter, which is having a very high energy. So that was stopped by this type of cable nets. So in summarizing, the flexible systems are now becoming more and more popular. So many families of alternate materials can be used, like steel wire mesh products, then polymeric products, then there are modified bitumen with plastic bricks. So I didn't mention that because of the limitation of the time. Then we can use locally available materials. Many of these systems can incorporate vegetation as a part of the solution. It can use the locally available soil. We don't have to go for very high selected fill. We can use locally available stones. We don't have to go for very selected stones of very high size. If for a slope stabilization for a river bank or for a coastal areas and all, if we are going for just a rock protection, we have to go for very large stones. But we can use small stones also if we are adopting this. And the monolithicity is marvelous. And India must embrace this type of tailored engineering solution, especially for disaster-prone areas. And all these systems are becoming more and popular in Asia, as well as our country like India and the neighboring countries, Nepal, Bhutan, and Bangladesh, because it is offering very big economy. So usually, I'm a part of an organization which is constantly offering the flexible type of systems. We usually claim 20 to 30% OD. Recently, one of the project head of a contracting company, he made fun of me. He told that you people tell 20 to 30%, but we contractors will never adopt if it is only 20 to 30%, because when we are adopting new technologies, so a lot of other risks are there. But we are adopting yours because this is someone who has given a lot of projects to us. He told me that we are adopting yours because the cost difference is almost 60 to 70%. If you are taking the speed of construction, the initial cost of materials, the overall economy, if you are considering, it is 60 to 70%. But we will not tell that to the client, because the client will ask us to share the profit. So that is it. We can use a number of new systems which are cost effective, which will accommodate the natural vegetation, which can reuse. Only what is required is to create more awareness, as well as have more standards and specifications, because that is then only we can use it in more effective way, especially in government projects. So that's it. Thank you so much for giving me this time. This is just like I would say, a brochure presentation, which is just giving a glimpse of the different systems, but a lot of engineering is there within it. So if you want to ask me a question, definitely means and say this is the time for it, and definitely you can write in my email ID m.korulla@matafree.com. Thank you.
Ma'am, I will be requesting everyone to ask you any questions. If there is any question through chat box. So could you please answer one or two questions, and the rest I request everybody to please mail ma'am so that you can get the answers to your queries. Before that, ma'am, I also wanted to discuss about Tata Cromont. You gave an example there, which is very close to where I live. And what I saw, being a civil engineer at home, the first question most of my family members actually ask is, oh, look at that structure. It is very much visible from any part of southern Bangalore, especially my area. So they ask, how have they constructed? How have they retained the soil there? So now I can answer them there. Thank you so much, ma'am. Thank you for giving that information. Anybody has any questions? Please type in, because ma'am has muted her system.
I'm so sorry. I wanted to be there physically with all of you, but because of some personal emergency, I had to be away. And definitely, any type of questions will be an encouragement, because that means that the session was giving some value to you.
Ma'am,
Okay.
Mr. Rajan Kamble.
I'm taking one question from Mr. Rajan Kamble. Seashore erosion solution. Okay. For seashore erosion solution, again, a number of flexible systems are there. What is coming to my mind immediately is the geotextile tube as well as geotextile bags. So these are containers, especially geotextile tube is a very big container, like 50-meter length, and diameter is say some 5 meter. So it can be filled with the soil. Okay. So otherwise, what are the seashore protection systems? Very big riprap, very big stones. And second, the tetrapod. These, because at present those type of stones are not available. Okay. In southern India, a number of places, the sea erosion is a huge problem. Huge problem. But the type of protection which is required is so costly. The government is thinking twice whether we should forget about for a while allowing the sea erosion, or whether we have to go for the protection. But definitely one day or another day we have to do something. Okay, because the erosion is so bad. And the geotextile tubes and bags are good solutions, but definitely it requires an engineering analysis. It cannot be like that we can just use it like gunny bag. Okay, so there are the analytical methods as well as softwares are there, how to analyze and how to install it. NIOT, National Institute of Ocean Technology, they are doing a number of studies in this, and I hope that in maybe within a few years, a number of coastal protection systems using flexible structures will be installed in different parts of India. Okay, again the question from Mr. Rajan, material used for soil and rock nailing. So see, the nails can be steel or it can be FRP, fiber. It can be from fiberglass also. Any other question?
Yes. Your email address. Ma'am has shared the email.
At the top, I am typing it. Okay.
I think I got a direct message, ma'am. I will let the participants know the mail ID. I'll give the mail ID to them.
Okay. Right. Yeah. I just want to convey this. Please, send your queries. Definitely, I will answer it. Only my request is, sometimes if a question is coming, it may take 2 days or 3 days, but be patient. Definitely, we will answer it. Okay, because I'm working in private sector, and in a we used to travel a lot for different sites and all. So sometimes the mails will be checked after a trip when I'm getting time. Definitely, it will be answered. Okay, one more question. Mr. Gauran Palulikar. In Ghats regions, there are frequent rock blocks due to rock falling or landslide. Why are these methods not yet implemented there? It's in Senasi, you will be happy to know that the last 4 years, the rockfall protection system implementation in India has became 3 times compared to what was the scene in 2017-18. Okay. So one of the reason is the publication of the ISO standards. ISO 17745-146 got published and it was Indianized. It got published in 2016, but the BIS adopted is in 2018. The Uttarakhand structures, whatever you have seen, and Mumbai-Pune Expressway, those were being done before ISO because it was such an emergency. They had to do, so they depended on the international guidelines. They didn't wait for BIS to publish. And there was a HRB publication, IRC HRB publication was there, HRB 23 was there. So they took some bold steps and implemented there because see, 4 people died in Mumbai-Pune Expressway. Okay, so immediately a minister has come to the spot. Before that, from 2013 onwards, people like my organization, we were constantly telling that there will be a problem, but there was no attention, there was no money. But when 4 people died, it became a political issue, and within no time, I think the funds were made available, and 40-50 crore were spent for just for 3 or 4 stretches, small stretches, rockfall protection. Okay, which could have been prevented by spending few lakhs, which has become a crore value project because it is not done in the right time. So the problem in India is the funds will be available only when we are seeing that a fatal accident is happening, which is unfortunate. Whereas engineering judgment has to be there before itself. And if the right time, the solutions are being taken, many times we can do with a small budget, effective type of rockfall prevention and all. But after the accident, it will reach to an unrepairable situation. Then we may have to, from the rock removal onwards, the expenditure will be much more than that. Here I will again highlight what Professor Neelima has presented. That's very important. We all have to get more and more familiarized with the studies, so that when we are a part of a system, we can very well tell that, see, these studies can be done, this planning can be done, and this much fund only is required now. If we are not doing that, what can happen after this? 10 times the expenditure will be increasing. But good, happy news, I am repeating that from 2018 onwards, definitely we can see that after this 2 publication has come from BIS, the 3 times the rockfall prevention and landslide control that has increased. So one of the solution is bring out the right standards, the right testing methods, because just companies are working, the clients will be confused. Because see, I am from McAfee. I may be talking for my business increase, right? Or my marketing of my products. But if a general guideline is coming and it is talking about how it is to be tested, how it is to be evaluated, how we can installed in a proper way, what should be the quality control measures, then that will give a lot of confidence to the clients. So that's why I have seen it as a commitment, individual commitment from my side. That's voluntarily I am working with a number of technical committees beyond my commitment to the organization which is paying me salary. Here, voluntarily, and it is not only me, a number of very dedicated, very knowledgeable people are working, and that's why we are now getting more these alternate technologies are in practice in India, and we can hope that more and more we will see the alternate technologies in the coming years. I have seen the question, are these stabilization techniques available for the remote northeastern states? I have shown one photograph of NFR that is from Assam. There are a number of structures are being constructed, flexible type, huge structures are being constructed in Sikkim. in Arunachal Pradesh. And I will say that for northeastern states, one should go flexible systems solely for 90% construction, because a lot of movements are there. The slopes are very unstable. If we go for rigid systems, definitely the repair will be very difficult. One more question for tsunami, any kind of design available? Tsunami. See, tsunami, we have to understand that the type of waves that will be quite huge. Okay, so we can go for the flexible systems, but at the same time, the special engineering considerations are to be there. Post disaster, see, we have done a number of structures post disaster. We know that I think 2004 a tsunami happened in southern India, and a number of post-disaster mitigation that is being done. But during the tsunami, if it has to act as an emergency protection, definitely we may have to go for something like huge geotextile tubes and mega bags that can really do something for the tsunami, okay, during the disaster.
Okay.
Thank you so much.
It is such an interesting topic, ma'am. Obviously, the questions won't stop. I'm sure many of us, including me, will write to you regarding our queries there. Thank you, ma'am. It was an honor. It was a privilege to hear you speak. It was really very interesting. Thank you for taking time out for IACEST. Thank you for accepting our request. On behalf of the organizing committee and the whole team of IACEST, I'm very, very grateful for your presentation and time, ma'am. Thank you. Thank you so much.
Yeah, it was my pleasure. Thanks to all.
Thank you.
And all the best for all of you for the upcoming sessions. Thank you.
Thank you, ma'am. Thank you so much. I thank all the participants for being a part of IACEST 2023. The link has been shared for all of you to fill in. Please contact us if you have any other queries. Thank you again for making IACEST online sessions a huge success. Thank you so much.